the first feature that we have is the defect insertion tool. See how we have all the MultiMech buttons on the top left of the property toolbox. In this case, we have two different sections, one with the liner and the actual composite. And by selecting the defect button, you can select the defect material. That's a material that might have a weakened fiber or weakened interface. And you can actually select the entire geometry and assign a certain percentage of random defects to that. Or you can hand select them by yourself. We give you the option. So once you insert all these different tools, you can run the simulation, and you can see how your global part actually responds to this. So when you look at the stiffness tensor, you can see where the defects were inserted, and these are the weakened elements that are in your model. And once you run the results, you can see how these different defects and what percentage of defects will actually affect your model and how the response occurs. One of the next tools that we have is the tool for injection molded parts. What we can do is we actually input a fiber orientation file. There's a wide range of different files you can work with. You can do something as simple as a .fo.mesh file, which just has the element and the normal vector associated with it. Or you can have an XML file that has a fiber orientation tensor, and that's what's outputted from, say, something like MoldX and MoldFlow. So once it's imported into the model, you can actually view the different fiber orientations through the button right there. And you can see visually where all the fibers are oriented. You can zoom in and see what your part looks like very easily. And then after this, you can run your result. You can run your model, and you can observe the results and see how the fiber orientation affects. You can see with the stiffness tensor here that the stiffness around the edge of the bolt and the edge of this connector have less stiffness. And when you run the results, you can see where failure starts to originate due to these differences in the fiber alignment. Finally, we have the new dehomogenization tool. What we have here is a composite bike frame, and this was run just using a linear analysis. And what we have is we have stress concentrations at these edges, and we wonder, okay, is there any damage occurring here if we were to run a multi-scale simulation? And maybe you don't want to run a full multi-scale simulation off the bat because it is slightly more computationally expensive. So what you do is you actually select your element and then select a RVE that you'd like to use to represent that element. In this case, we can use a carbon fiber element or a carbon fiber microstructure model that has damage. And what it does is it takes the strain history of this element and applies it to that RVE. And then after a few seconds, it'll run through the solution. And then at the end, you'll be able to observe how this microstructure responds to the strain history that you imported. So once it's done, you'll see the dehomogenization results in the dialog box next to the button. And so you can review the results. It'll bring it up in a GMesh file. And in this GMesh file, you can see how the different material responds. And in this case, when we run the solution, when you run the results, you can see some of the fibers starting to deteriorate. And we can see that maybe there is damage occurring at this part given our microstructure results. So it might be worth our time to run a full multi-scale simulation just to make sure and evaluate this more closely. And of course, you can look at the different results of the RVE, the different components, the 1, 1, 2, 2, and all the different shear tensors.